Cool. So good afternoon, everyone. My name is Ganesh. I'm a solution consultant at Databricks. I've been with Databricks for about 3.5 years. Co-presenting with me, I have my coworker.
Hi, my name is Ravi Gawai. I'm resident solution architect with Databricks from past 2 years. Over to you, Ganesh. I think you turned off the machine.
Cool. So today we're here to talk about building analytical application on top of Delta Lake. So let's take a quick look at the agenda for the talks. So we're going to start with...
You're not able to listen? Okay.
Are you okay? Okay. So we'll start with looking at what's Delta Lake and why do you need it. We'll also look at common Delta Lake use cases that we've seen with our customers, and what it means to build data as a service on top of Delta Lake to serve data out of your Delta Lake. We built a demo application, and when we decided to build this demo application, there were several design approaches, and we chose one particular approach, and we specifically targeted specific use cases, and we would be showing all of that. We'll have a live demo, and time permitting, we'll have a Q&A. So let's get started. So before we get into Delta Lake, I just wanted to set the context. So who here has built Data Lake? Awesome. This is a good audience. And out of you, who here has already built Delta Lake? Okay, great. So yeah, this is going to be an interesting talk for you guys. So this means that I can skip past some of the introduction slides about Data Lake, but just to quickly walk you through, Data Lake is nothing but a centralized repository that allows you to store all your structured and unstructured data at scale with lower cost. And it's not a new term. James Dixon, actually back in 2009, he coined this term where he draws this parallel between data mart and Data Lake. So he says that data mart, you can think of it as a bottled water, cleansed, packaged, and structured for easy consumption. The Data Lake, on the other hand, is a large body of water in a more natural state. The contents of the Data Lake stream in from a source to fill the lake. And the use cases of Delta Lake is, people can go to Data Lake, examine the data, dive in for more detail, or take samples out of it, right? So why do you need Data Lake? If you looked at Michael's presentation during the keynote today, he basically compared MapReduce with Spark and traditional data warehouse. So the challenges with data warehouse was really, it was expensive to build, store, and process your data. You were using proprietary technology, which means the code and data that the data format that you store and the code that you write were specific to one particular tool or vendor. So you were locked into one vendor. If you had new use cases and for that you needed a newer ETL technology, then it required rewriting your entire ETL code base, right? So you were stuck with that specific tool or vendor. And lack of machine learning capabilities. But, so with that limitations in mind, and with this proliferation of AI and machine learning, most customers aspire to use AI and machine learning to challenge, to solve business problems, and they started building data lakes. However, the reality was that most of the projects were failing. And the primary reason for why these projects were failing was because of low quality or unreliable data. In the data lake, there was a fragmentation of data. There were several copies of the data set, and they were not in sync. The traditional data lake, you could not merge, or you could not update them. You could not delete. It was mostly append. So what Delta provides us is the best of the both worlds. You get scale of data lake, open source and open standards. You don't get locked in to a specific vendor. you could have a Spark job running in MapReduce. You can bring the same job, run it in Databricks. It would just run fine without any code changes. Data format, when you write your data in Parquet format, using Delta or using vanilla Apache Spark, you could read that data from Hive, you could read that data from Presto or Athena. And it also provides you a unified platform for data and AI. What this means is that you can have data engineering use Apache Spark, and also data scientists use the same ecosystem, same platform for machine learning use cases. So you don't have to use another data science tools. Now, from Data Warehouse, we get full asset transactions. You're able to insert, delete, update, type 2 SCD, dimension support. And there's indexing concepts in Delta Lake to make query reads faster. And you're able, with schema on write feature, you're able to enforce schema so that your ETL pipelines, when the incremental pipelines are running, and suddenly you get nulls or data in unexpected format, instead of writing those data and corrupting your data lake tables, it'll just simply fail the ETL pipeline, and you can go and correct your source. And of course, scalable metadata handling. Delta doesn't depend on Hive's metadata handling capabilities. It maintains its own metadata about the table along with the data, and it dramatically reduces legacy Spark Hive operational burdens. This is very interesting because when I go work with customers, when I look at their pipeline that was basically built using Hive tables and vanilla Apache Spark, I see refresh table everywhere. I see MSCK repair table, right? So when your upstream table gets new data and the downstream table depends on it, when you're running this pipeline, you have to make sure that you refresh this table. Otherwise, you may not, this pipeline may not see the new data. Or if the partitions are being updated, you have to repair, right? So all of that operational burden is gone with Delta Lake. You can incrementally improve the quality of your data until it is ready for consumption. So I will talk a little bit in more detail in the next slide. And unification of batch and streaming workloads, again, Michael explained this, why you don't need Lambda architecture anymore if you are doing streaming and batch together as part of the same pipeline. So what's the Delta Lake? It's basically data lake powered by Delta. And if you're already using a Spark, and if you're a Databricks customer, you don't have to do anything else, right? And you can incrementally build your tables and expose tables depending on the use case to a specific set of users. The first raw layer, which is the bronze tables, are your, it's a raw data, being ingested from your ingestion pipeline. These tables are append-only tables, and these are immutable tables. You do not update them. And the reason this is super important is because if the state of the downstream tables, silver or gold tables, get messed up or they get corrupted for some reasons, or your ETL logic changes, your business logic changes to compute some metrics, you might want to recompute the state of your table. And in those cases, you have to now do the historical processing, right? So you don't have to go back talk to your source system and asking it to give you the data. You can simply reprocess or rerun your pipelines with the updated ETL code starting from bronze. And silver tables, you can think of it as, if you're processing transactions, let's say store transactions, right? So, and the lowest granularity is date. So you will want to maintain the same granularity at the silver layer table. It may or may not be joined with the dimension tables for enrichment, but you definitely want to filter them. You definitely want to typecast columns. You definitely want to rename columns so that they are much more readable to your data analysts and data scientists. Now, the gold layer tables is where you actually join your fact table. You might roll up your granularity from, like date level to maybe year level or month level. And then you might want to also bring additional dimensional attributes so that you have one denormalized tables. So data scientists or data analysts, when they want to query some data or they want to build some analytics, they don't have to join multiple tables, right? So that's the concept there. And you can have an orchestration to kick off this entire pipeline. For example, if you have one table in bronze, and then silver table is populated from bronze, and then gold table, it joins 2 or 3 other dimension tables. And dimension tables, you don't update often, right? Time dimension, you just load it once. Like the store information where you have store name, store location, you may not update that as often as the transaction table. So this entire orchestration can be done using external tool like Airflow. And if anything fails, the Delta maintains the integrity and you will receive an alert. So you will not have any partial writes, any duplicates data. If you have, if you write using merge operator, or if you use partition override, then you basically make your tables idempotent. So you don't have duplicates data in your tables. All right, so these are the common use cases we've seen across our customers, right? The simplest one is interactive queries. You saw Brock and querying the Delta table directly, and Brooke also, relying on Delta Lake tables to build analytics on top of that. You can also bring traditional BI tools, query the Delta Lake tables. You can train and build machine learning models. Creating data warehouse is interesting. Most customers think that, for data warehouse use cases for operational reporting and business intelligence, you have to push data out of Delta Lake into some, data warehouse technologies like Microsoft SQL Data Warehouse or Snowflake. You don't necessarily have to do that because your BI tools can hook directly into Delta Lake. But if the larger part of your business already depends on data warehouse, you can actually send the gold tables or silver tables directly to Snowflake or other data warehouse technologies, and you can have that orchestration, the downstream dependencies being set and run as part of the pipeline. The other use cases are interesting. Creating and monetizing your data product, right? So a lot of people ask me, what is data product? For me, data product is similar to data mart. It solves one specific business problem, and it gives you the entire context, which is the facts and all the attributes. And sell or share curated data to partners, vendors, internal customers, or external customers. Feed data back to source systems, web applications, or mobile applications. Now, for today's talk, we'll be focusing on these specific use cases. So when you want to serve data out of data lake, the common pattern that you see is that there are some clients requesting data, and how do you serve data out of Delta Lake to the client in the requested format at the requested frequency? So the first case is data product. So you could be building some interesting data products, and you could be sending that to web application. The second case is about data enrichment. Like your business executives might have, company level metrics that are being tracked from mobile application, and you could, have like North America, like region-wise metrics that you can directly send it to mobile apps. The third one is data integration. If you're using multiple ERP systems for different business functions, like HR you're using one system for HR, another one for payroll. Data Lake has all of that information together. But what if the What if the payroll needs some information that exists only in other systems, right? So you can use data lake as an integration point, and you can send that data. And the last part, the last use case is data export. This is very interesting. Data export, one simple use case is you have a supplier in Mexico, and they want to know how their product is doing in America or Europe. So you have all of the data because you are doing a business, you're selling their product. So once you have the aggregate data, you can, typically most customers, what they do is they write a SQL query, they generate the output, they either convert that to PDF or CSV, and then they send it to email, send it via email, right? But what if you could automate that, right? And it also has some approval process in between. So that's one use case. The other use case is you might want to replicate your entire data lake as part of your business continuity plan, either in the same cloud provider or in another cloud provider, right? So you're basically, in the backend, there's a background job running that's syncing your data lake. One is considered as a backup, so if something happens with this data lake, you can always depend on the backup version. All right, cool. So when you want to serve data from Delta Lake, there are essentially 4 layers. The first is storage. That's where your data resides, either on S3, ADLS, SDFS, and there's some concepts called catalog, so that you're able to discover your tables, your databases. And the next is compute. When you use Delta Lake, obviously, Spark and Delta makes an obvious choice. Now, this is the layer that is serving data out of Delta Lake. This is where you define your services that interact with the storage system and the compute, and you expose these services as an HTTP endpoint. And to this HTTP endpoint, your client, your different consumers can hook into, and then you can have various kind of services built around it. Now, this is not easy. There are lots of challenges, right? I really want to talk about the challenges. First, security, right? What if you accidentally leak data to the wrong vendor, right? What if there are some PII's data that were not supposed to be exported, or you send them unmasked? And, sorry. So latency and throughput and SLA, these are pretty straightforward. Data licensing, ownership, and monetization model. Monetization model is hard, right? How do you come up with a pricing for the data set that you want to sell, either in the market or to the supplier or the vendors? And managing evolving requirements, especially if it is an automated fashion, if your vendors are asking, hey, can you change this time format or the date format, or can you add this column? I don't want to receive this data anymore. Can you remove some of these columns? How do you, there will be evolving requirements, so how do you manage that in an automated fashion without having to rewrite your code and redeploy your code? Minimizing information silos. You could actually abuse these kind of systems, like, people might be just exporting data randomly on an ad hoc manner. So you have the same set of data residing in several places. Some data is in RDBMS, some in S3, some in ADLS. So you want to minimize that. So when it comes to data as a service, the key features or the key characteristics are, it's read-only. You do not allow mutating your data in Delta Lake from these APIs. You should be able to handle any data format, right? If you are exporting data to a web application that was built in 90s, it will ask you to send it in XML format, right? The modern web application, mobile applications, they will accept JSON format. Data scientists, they might ask you to send it in CSV format. So, a delivery mechanism, they might ask you, hey, I know you are in Azure Databricks, but can you send this data to my S3 bucket or Google Cloud, right? Or can you write this to FTP location? Because that's where I'll pick up the file from, and then I'll do further processing. And then, of course, you want to expose everything as REST APIs. All right. So for the remaining portion of the talk, I would like to invite my colleague, Ravi, to give you a demo and talk about the use cases.
Thanks, Ganesh. That was really awesome explanation about what's Delta Lake, what's its feature, and wonderful explanation how data as a service can be implemented with then architecture. So let's talk about the use case we focused upon for our demo application. So I have worked in e-commerce verticals a lot. So the use case I can correlate is in e-commerce you have this product catalogs or the merchant's data which you are selling, and the data is coming from various merchants. So and then you can make aggregations on that particular data, and can you expose that particular data to your internal or external systems. So with this particular use case, we have like two requirements. So the first requirement, what we thought is, can we build an UI which can interact with the Delta Lakes? The second use case is export a classified aggregated classification data, which is an aggregated format, and serve it to internal customers using Delta Lake. So in this particular scenario, assume that you are getting an sales order data. So what does that mean is you are getting a product title or maybe a product description, and you're getting how many counts are sold, but then you don't know how your sales are happening, and you want to create an insight based on just an order data. So how can you do that? So basically, I can do classification based on the title. So I can create an ML classification algorithm which will read these product titles and create a classification tree based on my own taxonomy. This is because I want to create my own taxonomy because data is coming from various merchants and they have their own taxonomy. And when I want to aggregate data across the merchants, I will have my own taxonomy. So I will create my own machine algorithm which will classify. And this is what this use case talk about, like export classified and aggregated data out of Delta Lake. So what are the features of this particular demo? So there are three particular features that we will be demonstrating. The first is we will have in this end-to-end pipeline which will gather data, the sales order data from various merchants, and apply this machine learning which will classify and create and categories and subcategories so that we can see how the sales is happening. Once you have this data dumped into Delta Lake table, then you need to actually expose this particular data as a service. So we have created this REST applications. Using that, we have these endpoints, and these endpoints basically will export the data from Delta Lake. Then lastly, just for the demo purpose, we created this front-end application as an end customer. So imagine this front-end application can be an internal or external, because you have already created a service for exposing your Delta Lake, and then that service can be consumed internally or externally also. Just to simulate that, we have created this front-end application so that we can create dashboard, so that once the data is out, I can create an insight on that sales order information. So let's talk about our implementation detail. We saw that what are the different levels or layers that needs to be implemented in order to implement data as a service. So the first layer is storage. So what we chose is we have a catalog system. For that we have used Hive, and data we will be storing in Delta Lake, which is powered by S3. So all your data will be residing on S3. The second, you need a compute, because now you have this data residing in Delta Lake, but how you will be accessing that data? So you need some sort of a compute, and that is Spark. So we are using Databricks powered Apache Spark cluster on AWS. Then comes the important part, is the serving. Now you have your goal tables of order categorization in Delta Lake. you have your compute ready to serve that particular data, but in order to expose it, you need a serving layer. So what we did is we created a simple REST application in Play framework with Scala. So those who are familiar with Play, Play generally have routes for those endpoints. So what we have done is, in order to expose the data, we have to fulfill those data-specific queries and point it to Spark so that Spark will use its compute and fulfill those queries. So internally, we will be calling the Databricks Jobs API. So basically, if you're not using Databricks, you will have your own managed Spark cluster. But when you are submitting the queries, you need to track those queries. Because even though you are exposing this data as a service, this won't be an synchronous call. Because you are making queries against the Delta Lake. It will be an asynchronous call. So you will creating those Spark jobs. And you need certain identification to keep track of those Spark jobs. So for that purpose, we are using Databricks Jobs API because it gives you that platform which actually takes all the job-related informations and serves you, rather than you manually going and checking what's the Spark job ID and the status. Then the last layer is consumer. So this is our front-end application that we built in React. And then this particular application will use this REST endpoints to export the data out. But in order to export the data out, you will have to store that exported data somewhere. So we are using S3. So the use case is something like this. You have this data as a service exposed, and this front-end application is consuming those APIs. Then this front-end application is telling, I want so-and-so data exported on so-and-so location on S3. So we talked about this implementation details. Then in order to implement this data as a service, we need endpoints. And we thought about what could be the basic endpoints that we should be implementing. So the first API we thought about is metadata API. Because we have used for cataloging, metadata cataloging, Hive. So you can make a synchronous call to your metadata and get all the metadata information, like what are the databases you have. In that databases, what are the tables you have. And the good part about this is you can take control of what sort of data you want to expose to the outside customers and what sort of data you want to hide. So you can take that control in your service layer, or in our case, we can pass it on to Databricks platform also. We can handle who can access what sort of data. So you get that liberty to choose the layer of who will be accessing the data. The second use case, second endpoint we thought about is, now you got to know about where is the data and what is the data. But in order to actually see what sort of a data details it has, we thought about having a preview API which will throw some 100 rows just to showcase that, okay, I'm interested in like order categorization data, but how does that data looks like? So this API will give you that particular 100 or 200 rows just to peek through the data. Now the most important endpoint is the export. So these are the SQL APIs. So we have two metadata APIs and we have two SQL APIs. So this export SQL API takes the input as SQL, because so far you got to know about database and tables. You figured it out that these are the sort of tables from which I need to export the data. So I will provide that query to this endpoint. Then I will provide the path where this exported data should be saved. Then the third and important part is you can also provide the format in which you can export this data. Let's say I want that data in JSON format. Some other system want that data into a Parquet format or CSV format, so that your data service should have this capability to handle multiple types of format and export the data. Now, I talked about like these requests or these query requests will be fulfilled by Spark, and Spark will be creating jobs. And these are asynchronous types of communication, so you need some sort of a track ID to track those exported jobs. So we thought about the last API is get the run status. So while firing this export SQL data, it will give you a response as a run ID, so that this end system can actually keep polling on that run ID, saying, what is the status of my export output? So based on, like, we can maintain some statuses internally the way we want to, like in progress and maybe completed or some sort of an error, so that based on that, the client system can decide what sort of actions can be taken. So these are the basic APIs we implemented. So let's go over the demo now. So in order to fulfill those export Spark SQL, what I have done is I have created a Spark job, which is, I have created two set of jobs. So one is your main ETL job, which is product categorization job, which is reading that merchant's order data, classifying it, and putting into a delta table, which in this particular case is a gold table because that is ready for consumption. The second sort of job is the delta service job, which will take those SQLs which is coming from an export API, fulfill those SQLs, and write an output to a desired location. So these are these two jobs. And we have also built this front end. So since we are backend developers, the hardest part was to build this REST endpoint. So just bear with us with this UI. So let me check this UI is up and running. Meanwhile, we have this REST endpoints, which are up and running. So let's go over our web application and access those APIs. So like first thing I talked about is you need to have the getDB metadata APIs so that you can explore the database. Okay, so these are the database my catalog is having. So this request is going directly to your Hive, so that's the reason it becomes synchronous request, and you can populate all the databases. So let's say I have this Delta Service demo as a database which has these tables, or sales or retail. In our case, our use case, we have written that order categorization into order categorization table. And we can actually see what's the schema looks like. So what we have done as a part of that ETL pipeline is taken the product description, and it has created 3 extra columns as a prediction for your classification tree, which is like what is the root category for that particular product, what is the subcategory, and what is the child category. And also the last one, it talks about confidence. So now you have built this machine learning algorithm, and data will be consumed by outside systems. If I'm providing the confidence in prediction, the outside system can decide based on the confidence, like I need 90% at least confidence in this predicted data, then only I'll export. So this becomes a useful field. Then this is the preview so that you can get to see the preview. And let's do some export. So let's try to find out, since we have this sales order, let's try to find out in particular category how that sales is happening across the subcategory. So I will select an output path. This is an S3 location. Then I will select the format as in JSON. And let's write a query that select subcategory, then sum of your item counts as item count from, let me copy paste because that's what we do. Yeah, I'm a lazy developer. Where your root category is, let's say we are targeting clothing. And then you can say group by your subcategory. And then you want this data to be exported. So see, it has given you a run ID so that you can track that run ID. And then once that run ID says, okay, job is completed, then the data is ready to be exported. So this will write that data into this S3 location so that we can build the dashboard. So the dashboard like we built is the basic one, which is you can showcase the product sales by category. So now we have chosen the root category as clothing, and the subcategory are like, with our taxonomy, we just have 3 categories. That's men's clothing, women's clothing, and baby and kids clothing. So based on this insight, we can decide, like your marketing or sales team can decide what sort of campaigns you want to run. Or you can dig deeper into particular category to get to know how is sales happening in women's clothing, or how is the sales distributed in men's clothing. So these are the sorts of insights you can create based on these data as a service. So that concludes my demo. Over to you, Ganesh.
All right, you saw the screenshot. I hope you really like the demo.
Yeah. Nice session, Ganesh, Ravi.
Yeah, we got about
Yeah, we got just about
3 minutes.
Time for
Here's our
Q&A.
contact information. If you have any questions, you can always reach out to us directly. But yeah, feel free to ask any
We can have a Q&A for a few minutes. Any questions from the audience? Awesome, all good.
All right then, thank you.
Wonderful job.
Okay.